In class, we did number 1 and number 2. On the next part of the homework assignment, it says find the vertical asymptotes and holes for the graph of each function. So right here, we're going to go ahead and do number 4. And what I'm going to do is I'm going to factor this. So I'm going to write it in factored form. So you have y equals 5 minus x over x plus 1, x minus 1. And if you look at the denominator, that tells you where the vertical asymptotes are. So what I'm going to do is I'm going to go ahead and type this in. I have 5 minus x. And of course, the denominator is going to tell me where the asymptotes are. So we have x plus 1. And then we have x minus 1. And you notice that the vertical asymptotes occur at where it's undefined. And by looking at your table, it's undefined at 1. So let me write your vertical asymptotes. X equals 1 and x equals negative 1. So we're at 1, and if I scroll up, negative 1. So those are the two places that we have our vertical asymptotes. For number 5, we're unable to write it in factored form, but if you notice, I did graph it here. And if you want to know where the vertical asymptote is, you can always go to the table to verify. And you notice what's going to make the denominator equal to 0, because if the denominator is 0, then it's undefined, and we notice that it's going to be negative 2. So the vertical asymptote is at x equals negative 2. Okay, for number 6, it is written in factored form. We notice that at x, we have a hole. So it's going to be discontinuous at x equals 0. And we also know that the vertical asymptote is at x equals 1. Unfortunately, I wasn't able to graph it. But remember what I said, if x divided by x will cancel, that's going to be your hole. And then, of course, you have 1 over x minus 1. So the vertical asymptote is going to be at x equals 1. Number 7, I'm going to write it in factored form. So I have y equals x plus 3 over x plus 3 times x minus 3. And you notice that in the numerator we have x plus 3. And in the denominator we have x plus 3. So our whole is going to occur at negative 3. And if you look at our denominator, the vertical asymptote is going to be at x. It will be at x equals 3. So I'm going to go ahead and show you, here's a graph. And we have the vertical asymptote, which is at 3. And if we go to our table, we will verify. So at 3, it's undefined. And also at negative 3, it's undefined, so there's a hole at x equal negative 3. Number 9, we notice that we have x minus 2, and x minus 2 is going to cancel, so we know that the hole will exist at x equals 2. Our vertical asymptote will be at x equals negative 2, and what I'm going to do right now is I'm going to graph that. So you can see that number 9 is graphed on the screen, and we know that the hole will exist at x equal 2, and we do have a vertical asymptote at x equal negative 2. So I'm going to go to the table, and you notice that at x equal 2, it's undefined. In the lesson, I taught you how to find the horizontal asymptote of the rational function algebraically. You have to look at the exponent. And you notice that in the denominator you have x to the first, And you know that in the numerator, there isn't a value of x, it's just 1. So definitely the higher power will be in the denominator. Therefore, the horizontal asymptote is at y equals 0. That's the horizontal asymptote. So if I look at my graph, I have it shown here. Indeed, the horizontal asymptote is at y equals 0. For number 11, we're going to look at the two highest powers. So we have 2x squared, and we have x squared, and this is just exactly like the notes. Remember, these two are canceling, so the horizontal asymptote will occur at 2. And you notice right here, our horizontal asymptote is at 2. And I can verify by writing a 2 there. And you notice there's a horizontal asymptote.